the lunar habitats, right? So it basically writes all that in whatever I'm trying to tell you. It's all written like this, that you can put it in a paint, applying this compound in the inside surface, and then monitoring and data recording will be a visual monitor with a view of the area of interest and time recording and flashes. So these flashes could be integrated over time in order to obtain a gross measure of the aggregated damage of that period. Right. So basically, once you have this material, it will be used as a sensor, and the rest of the things all the engineering people have. So once you have it, it is a very nice thing. Right? Then this micrometeoroid bombardment, and in the end, you basically will have a assessment. There's a lot of work to be done, but once you have this material, then you can use it for that. Right? And of course, these are some of the ideas which we had in statement here. That if it is a large meteorite, that will be lethal, it can just damage the whole thing. Right? Then it is beyond us. But if there are small ones, then you can just integrate those. Okay? So essentially, this is obvious that you want to have a habitat, you want to know what is the life of this roof. And at that time, it should not leak during the time you are doing it, right? So essentially, that is one of the applications. There are many other applications. One of them we have even worked on it here, which I'm going to bring it to your attention right now. So you can actually use them in optical damage sensors for defense applications, right? So they need a lot of things like this. In defense application, if you have a material which can be used for damage sensors, right, this material can be used. And these sensors can be used for structural health monitoring of space vehicles to give real-time indication of the impact, right? So anything, these things are also can be used in ship hull applications for Navy. They also know when they are going in the sea, and if something hits their ship, they want to know how much damage it has done. So at that time, if this is the material in front of that, it will give them the light, give them that idea of how big the impact is. Right? So actually, Navy has this interest also. And this can also be used for NASA crew launch vehicles and crew exploration vehicles. It can be used for airplanes for condition-based monitoring. Now this was a big thing, condition-based monitoring. They used to call CDM. That is nothing more than after so many flights, they want to see the integrity of the structure. So they do, like engineers go and see every part of it. See part, whatever your equipment is, you can see that. So that they used to call it condition-based monitoring, and then they keep changing the names. But basically, after some time, you want to see how good that is, right? So essentially, that is how to make them sensors wireless. Okay, one thing is you have to have like 2 wires on the sensor. So if the light goes, you have to take that signal and see how much signal that is, right? But you want to make it wireless, right? For making it wireless, there is something called RFID tech. All right. Now this is so cheap that Walmart uses in their all the artifacts there. So every little shirt you take it out, they have some kind of RFID sensor. Anything there, so cheap. And then once you take it out, they know that it has gone. Right? So that's so we are still working on it. It could be used in brake systems for auto industry. All right. So as of now, there is a squealer in the brakes. So when it goes way down, you get some kind of a screeching noise, and then you go to the to change your thing. But this will be, if you put a layer very close to the end, then it will just grind and give you light, and that light can be converted to electrical signal, and it will tell the driver that hey, you need to go and change your brakes. Right? As of now, it is not put in there, but it can be. So it is that a layer of triboluminescent material can be embedded at the appropriate place in the brake pad, and this material with the photon detector combination can generate a signal. Right? All the details are given. Some of you, of course, if you understand when I'm talking, is great. But if you don't, everything is written out, and you need to really go over. And then if you are still here, I understand, and we can talk more about it, and if anything strikes your fancy. Right? So essentially, this is also, we have a laboratory system designed and fabricated to test this proof of concept. And this is how it looks. So we have basically we buy a brake pad, a brake drum thing. I think we have a machine shop and a very good machinist here, Garland. He's the one who did this. All right, we went and got this brake pad. This is brake pad, and this is the drum. Right? What do you call it? Rotor? Rotor. So the rotor, a rotor of a car, we got the smallest one. Okay, so it did not, there are big sizes, but this is the smallest rotor. And to mimic the car, we have this motor which drive this. Okay, so it is driving this, and then we have this pad here, and we put a triboluminescent material here. Then it is made to take in here, it grinds, and it gives you the spot, okay? It gives you the light. And then when that light comes, you can convert that with a monochromator and stuff. I think you helped us one time, he had the optics part of it that, you can see that signal, and then that can be transmitted to the dashboard, okay? If it is a auto industry wants to take over, that would be great. Right, so I've given you a list of some references you might like to see. This is a review article on triboluminescent by Alan Walton, 1977, and then there are a series of things. People have done various things on some of these materials and related materials. So if you really want to know anything, there is a list of references I've given. Right? So of course, as I told you, you can see my technical memorandum, which is I've given you a reference in between them. And I guess that may do the trick here. I thank you for your time.
Perfect timing.
Nice. Any questions?
Yeah, sure.
Yeah, you said that you could control the crystal size with the addition of biffering. Is there any decrease or increase to the triboluminescent effect based off crystal size?
And not based on crystal size, we don't have the change in that triboluminescent material. It is just the size. Yes.
If the effect comes from the crystal fracturing, is there any effect on the durability of the signal? It seems like a larger crystal has more places it could maybe read signals more times than being broken down.
Yeah, well, you have a point. Like if you have a large number of crystals broken, you will have the more intensity, right? So that is only the difference between the bigger size and the smaller size. Like you have to break the crystal to get the light. Now it will depend on how many bonds are breaking, and if you have a bigger size, it will break lot more bond, and then it will be lot more intensity, right? So that's it. Yes.
In the application for the brake pad, is it possible that you could lay, say, the undoped triboluminescent material first? Because we all know that people ignore the squirrel on the brake pads for a while and usually wind up ruining rotors. In order to do that, could you layer the, say, the undoped and then layer it behind it with dope to increase the intensity? Is that a possibility?
Yeah, well, that's a good application thing. Yes. We have not, as of now, it's a proof of concept. So we were trying to put some material and try to see whether it will work. And then later on, like what you are saying. That's a kind of, it is a very good idea that hey, if he does not heat to the first warning, give him a bigger warning. So something like that, yes.
I was talking about something like I use weather sensors like in the soil and river banks in the cellar. And your methods it takes to remove the water from the substance. So would that affect like to have like fish applications and weather sensors?
The water sensor?
Yeah, like livestock sensors in the soil, the pH, groundwater, and cellar, and the sensors in the water. Like however your method used in hydrogen for the curation. So like would that affect if you use it to be used in like in water type of environments like sensors?
The sensors will be used, can be used maybe underwater if you are asking that.
Yeah.
But
So like you see like I yeah,
sure, yeah, you have to kind of put it in some kind of a wrap which is kind of water resistant. Because this is just when you crush it, the light comes off. And that will work even if it is underwater. Basically Navy is using that. Navy for the ship hull, it is inside the water they use it. And if that is what you're asking.
I think also, if I understood him, what he's saying is that suppose your crystals absorb water, then the efficiency probably goes down, right?
Yes, that's
Yeah.
And so can it be used for say soil moisture sensing?
Soil moisture sensing, my gut feeling is no. Because I worked on the soil moisture sensors, and what we did was the ultraviolet, ultrasonic propagation through the soil with moisture and without moisture. And then you measure the velocity of sound. And then that gives you a sense
So
of.
I think what he's trying to say, what Dr. Sharma said, that the nitrous part is very important. So if the soil moisture is coming to the sensor, if we have a calibration done between the intensity of the triboluminescent sensor without any moisture, and then if you put moisture as a controlled moisture in the chamber.
Yeah, but I know the soil moisture.
Yeah.
It's very crude stuff, and it is very, very good.